This lesson is going to focus on a review of metric prefixes along with dimensional analysis. So this slide and the next give you a list of the metric prefixes which you must know. A reminder that they're all based on the base units: meters for length, liters for volume, grams for mass, and seconds for times. So our base unit symbols stand alone. The prefix symbols are always combined with one of these base units. So for example, if we take kilo, we could write kilometer, kiloliter, kilogram, or kilosecond. We're going to use these in order to write equalities to help us make conversions. As the table is written, each of our equalities are such that if we write one of the prefix value, it will equal so many of the base unit. For example, a megagram, we would say 1 megagram is 10 to the 6th grams. The exponent for mega being 10 to the 6th, the base unit for megagram being gram. Let's take a hectometer. See if you can write the equality that would relate a hectometer to its base unit. Please write in your notebook. Hopefully you wrote 1 hectometer equals 10 squared meters. Now we're looking at additional prefix list here. Take notice that we use a single D for the symbol for deci for 10 to the minus 1, not to be confused with on the previous slide, deca 10 to the first was the symbol DA. We won't have any confusion between millimeters, which uses this, milli, which uses the symbol M, and meter, which also is an M, because milli must be combined with a base unit. So we have mm for millimeter, whereas a simple M all alone could only mean the base unit itself. Let's try writing an equality with one of these prefixes. Let's write an equality for the relation between a microgram and a gram. We want to put the 1 with the prefix portion, so it would be 1 microgram equals 10 to the minus 6 grams. Now, we want to use these equalities to do dimensional analysis or factor label, so we're going to rewrite this simple equality as a fraction. If I write that as 1 microgram over 10 to the minus 6 grams, that because it is an equivalent value, that would be equal to 1 as a fraction. Similarly, I could write that as 10 to the minus 6 grams over 1 microgram, and that would also be 1. We'll find that when we do our factor label method, our choice will depend on the conversion we're trying to make and which unit we want in the numerator or the denominator. Now, in your notebook, I would like you to write an equality for centimeter and meter, and then the two fractions that we could write to go with that. Hopefully you wrote 1 centimeter equals 10 to the minus 2 meters, and that your two fractions would be 1 centimeter over 10 to the minus 2 meters, or 10 to the minus 2 meters over 1 centimeter. Okay, now I think you'll need to pause this for a moment and go get a calculator Maybe you even want to pick up a snack while you're doing that. Now you're going to want to copy these rules for following the factor label method that you can refer to in the future. I want to tell you that as we do some of the metric conversions, I know many of you can very quickly move the decimal left or right and give me the answer, but we're more focused here on using a method that's going to allow us to make complex conversions throughout the year, and we're going to use this method to solve many different problems. So the method is more important than the quick moving of a decimal here if we're using this method for making metric conversions. So our first rule here, we want to make sure that we write true equalities using our prefixes. So that means I want to put the exponent with the base unit and the one with the prefix. So if we were talking about megagrams and grams, we'd write 1 megagram equals 10 to the 6 grams. Writing all numbers as fractions with units, what we mean there is if we had 35 centimeters as a measurement, to use the factor label method, we want to write it as 35 over 1 centimeters. We want everything as a fraction. Looking at the equality in the first example, we would write that as a fraction, 10 to the 6 grams over 1 megagram, or I could similarly write 1 megagram over 10 to the 6 grams. Whether I want it in the numerator or the denominator is going to depend on what conversion we're trying to make, and we're looking to cancel our units. So we're going to have a series of fractions that we're writing with numbers and units. And when I go to enter them into my calculator, we're going to want to remember that any number that shows up on the top or the numerator, we will hit multiply when entering in the calculator, and any number that is in the denominator or the bottom, we will hit divide. Okay, so let's do an example. And a reminder, we're more concerned with learning this method than being able to move a decimal left or right real quickly. So in our first example here, we want to convert 2.4 kilograms to grams. So I'm going to write my 2.4 kilograms as a fraction. The equality I need has to deal with kilograms and grams. So 1 kilogram is 10 to the 3rd grams. So I can write that as a fraction one of two ways. Picking it depends on trying to cancel my units. So my kilograms in my first factor here are in the numerator, so I want to choose the fraction where kilograms would be in the denominator, so they would cancel out. Copying that fraction, see that kilograms cancel, and when I do my math, 2.4 times 10 to the 3rd is all in the numerator, so I am simply multiplying, and I have my final answer. Our second example is going from kilometers to centimeters. That is not a base and prefix equality, so we're going to have to do 2 steps. I know that I can go from kilometers to meters, my base, and my meters to my centimeters, again related to the base. So when we say kilo, we think 10 to the 3rd, and centi 10 to the minus 2. So now to get started, we copy our 6.5 kilometers over 1 so that we have it as a fraction. And now I know that I want kilometers in the denominator and meters in the numerator for my first conversion in order to have them cancel. but I need to make it a true equality. So I put the 1 with the kilometer and the 10 to the third with the meters. My next factor, I know this time that I want meters in the denominator and centimeters in the numerator. Have to make it a true equality, so I put the 1 with the centimeter and the 10 to the minus 2 with the meter. Everything in the numerator I'm going to multiply by. Anything in the denominator I divide. So I'm going to get 6.5 times 10 to the 5th centimeters. Our last example is one that involves a conversion between the metric and the English system. So we need some conversion tables found on your text, page 16, and the appendix 26. You might want to mark those in your margin. You're going to use those frequently in the next few days. So we see that on the conversion table, we can go from centimeters to inches directly to get from metric to English. Then we'll have to go from our inches to yards. So we write our 16 centimeters as a fraction. I want to get rid of centimeters, so I need to write a conversion between centimeters and inches, with centimeters being in the denominator. I look on page 16 and I find that the equality is 2.54 centimeters is 1 inch. So I have to put those with the appropriate unit. Now, I want to get rid of inches, and therefore I put inches in the denominator and yards. And we all know from that 36 inches equal 1 yard. So we write our equality as such. And now, to enter it into my calculator directly, remember anything in the numerator, we're going to hit multiply, and in the denominator divide. So we'd have 16 divided by the 2.54 divided by 36. For significant digits, I look at my original problem. The 16, it's the only thing that was measured, has 3 significant digits. So I'm going to plug that in my calculator. 16 divided by 2.54 divided by 36. Round to 3 significant digits and get 0.175 yards.